Imagine using an AI image generator a year ago. You'd type in a prompt, hit enter, and hope for the best. It felt like playing a slot machine. You'd pull the lever over and over, constantly tweaking your words and praying the machine would spit out something close to your vision. Even a win came with rigid limitations. You were locked into fixed square or landscape aspect ratios. If you tried to include text, you got alien gibberish. And if you asked the model to place a specific object in the background, you quickly realized the system had no real concept of spatial relationships. The update to ChatGPT Images 2.0 introduces a different mechanical logic to this process. It replaces that random slot machine experience with a system designed to interpret specific, complex instructions. This change places the user in the role of a creative director, commanding an intelligent partner that processes the world through data and geometry, rather than just random pixel patterns. To bridge the gap between imagination and execution, the system first had to master the physical canvas. It now supports precise, variable aspect ratios. You can request a tall 3x1 vertical poster or a massively wide panorama, and the model structures the frame to those exact dimensions. We can see this spatial understanding in its ability to handle geography. When asked for a view from the top of Half Dome, the model generates the image in a seamless 2x1 ratio, recognizing that this specific aspect ratio is the standard for capturing a panoramic landscape. This expanded canvas is backed by an upgrade in pixel density. While previous versions were limited to 1K resolution, the new model supports up to 2K. Doubling the pixels allow these outputs to function as sharp, print-ready assets. This resolution is clear enough to render microscopic details that were previously impossible. You can now prompt the model to display a single grain of rice and find perfectly legible text rendered across its surface. That legibility extends globally. The system has been trained to generate dense paragraphs across complex international scripts and character sets, ensuring the text is accurate and readable regardless of the language. In a chaotic urban scene like this Tokyo street, the kanji on the illuminated signs is rendered correctly. This demonstrates an understanding of how characters should look within a specific cultural context. We see that same precision when the context shifts to Seoul. The model correctly identifies and renders the architectural style of the Sungnoman Gate, alongside modern skyscrapers and Korean typography. By combining precise framing, 2K resolution, and reliable global typography, the AI functions as a legitimate tool for commercial and global design. Beyond resolution, the model now possesses spatial intelligence. It can take a list of multiple objects and map each one to a specific location within the frame. Early models often ignored positional commands, but the new system treats the image as a coordinate plane. It responds to instructions by snapping objects into place based on their relationship to one another. If you prompt for an apple in the center, a mug to the right, and books stacked above the mug, the system maintains that strict relational hierarchy. This also allows the model to override the deep-seated biases found in its training data. For example, because the internet is full of watch ads, most AI models default to showing clock hands at 10:10, regardless of the prompt. Images 2.0 ignores those tropes. If you specify a time like 2:30 or 7:45, it renders the clock hands in the exact positions you requested. By prioritizing your spatial mapping and specific timestamps, the model demonstrates that it follows human intent over the patterns it learned from the web. All of these features culminate in the thinking protocol. This transforms the AI from a renderer into an active researcher capable of synthesizing external information. The model can now ingest massive external documents. You can upload a 100-page PDF and ask the system to identify the core thesis and key findings. It then translates that extracted data into formatted visuals, such as a self-contained slide deck or a portrait academic poster, without sacrificing technical accuracy. The system can also search the live web to solve open-ended problems. If you ask for a product advertisement for rare merchandise, it can find real-world pricing and resale values to include in the final mock-up. This Latin title page of Newton's Principia Mathematica represents the kind of historical knowledge the system can now reference. It can search for Newton's major scientific contributions and synthesize those facts into accurate, multi-page educational infographics. It even handles subjective research tasks. For instance, it can analyze social media aesthetics between 2006 and 2026, synthesizing 2 decades of visual trends into a single report. These capabilities result in a system that delivers comprehensive, thoroughly researched visual solutions, rather than just standalone images. The current state of image generation provides precise, agentic control over the entire creative process. This control is the key to closing the intent gap, the distance between the idea in a creator's mind and the result the machine produces. Because the model follows instructions so strictly, you can produce consistent, multi-page outputs, like architectural floor plans, manga comics with recurring characters, or entire magazines. Image generation has become a tool for discovery and a partner for building the world.